And hello, this is a demonstration of a working OPC UA server written in Python and Rust. So so basically what it does, if you take a look here, I have a Reynolds number. I can set it to a specific value. So this is Reynolds number equals 5000. Now let's change it to a Reynolds number or something maybe more familiar. So Reynolds number is actually the friction factor, Darcy friction factor is 64 over Reynolds number. So if I change this to 64, my Darcy friction factor should become 1. You see, Darcy friction factor is 1. If I change this to 1800, it should be much less. Darcy factor equals to 0.04. So let's open LibreOffice. Okay, and then we can check whether that is true. It should be okay. Yeah, so this is all based on a Churchill friction factor code that's running at the back end. So yeah, this is the server code right here. Yeah, this is the server code, and I just added some bunch of methods here. As you can see, I actually added 2 codes here. One is called Rust Darcy. So Rust Darcy just does what it says, calculates the Darcy friction factor, but it has a Rust backend. So where's the Rust code using? Okay. Anyway, let's just see whether it's really 64 divided by 1800. 0.033556, something like that. So yeah, I think you need a bit more significant figures. So let me give this like 5 significant figures, so that you can see what it is. So I'll change this to maybe 5 significant figures or 7. So yeah, I can change the value of the Reynolds number here. Oh boy. Yeah, I can reconnect. I can change the Reynolds number here. So let me close this. Actually no, I'll switch to another workspace. Move to desktop 2. Yes, okay, so I'll disconnect this and I'll reconnect. Yeah, so this is the OPC UA, free OPC UA graphical client, which makes it such that you don't have to think too much about. Yeah, now it's lagging, great. Let me close this. Okay. Yeah, close, thank you. Clear. Okay, let's try OPC UA client again. Okay, so this is a graphical user interface OPC UA client. This OPC UA server is running on my other laptop. So it's actually on SSH. Yeah, this is on SSH. And this laptop, this particular laptop I'm recording on is another laptop. So I'm connecting over the IP address 192.168.214 or 241.4840. So if you can see here, let me go and check the IP address right here. IPA. Okay, 241 is the place to go. So you'll use 241. You can connect. And just to show that, it's a different computer, I can do a neofetch or IPA here. You can see my IP address is different. Okay, ZSH IPA. So yeah, here's 245, right? 245. So it's a different one. Neofetch is a different. This is on my IdeaPad. Whereas when I do use my SSH, I do run neofetch. This is on my other PC. So yeah, it's running on different computers, and basically it's running remote operation over my own Wi-Fi kind of a thing. So let's change the Reynolds number. Okay, I'm going to change the Reynolds number here from 160 maybe to 64. Okay, 160 to 64, Darcy equals to 1. We will change it to 1800. 1800, and what's the Darcy factor? 35567. So this is exactly what we see here. Let me close this. It's not useful. Yeah, 64 over 1800, about 35556, something like that. So you see, it is working. Alright, so let me show you the Rust code. the Rust code is right here. I'm not going to go through the source code so much now, but yeah, at the back end it is running Rust using PyO3 maturing thing, and then I have a few bits of code here which I just copy and paste and reformatted from my C# code so that it will calculate the Reynolds number using Churchill friction factor. So this is just a very simple demonstration, but it shows that the thing is working. Yeah, so woo! Yeah. Anyway, so let's change it up. Maybe 350 Reynolds number, and here's the Darcy friction factor. It sort of increases, and in theory, if you run it maybe to 200,000, the Reynolds number should cause the Darcy friction factor to sort of decrease. But maybe this roughness ratio is very high. That's why. Okay, so yeah, 200,000. So this is a very rough pipe, very rough pipe. So maybe 8, maybe I'll put 8E 6 maybe. What? 8E6 is invalid literal for int. Okay, whatever. Maybe 8 to the power 10. Whatever. I think it cannot like calculate on the spot here, so maybe we'll just do 8000000, and it should work. Yeah, so yeah, we are like so-called inside the rough region already. So this is a very rough pipe. That's why the friction factor is high. I set the roughness ratio here to about 0.15, as you can see. 0.15 is here. I can of course change the roughness ratio to something else later on, but again, not superbly important. But yes, so I'm able to change the Reynolds number, and this OPCUA code will, this OPCUA server will just take the Reynolds number. It will push it through a friction factor code using Rust, and it will churn out the friction factor. Okay, so this is just very much sandbox, but you know, things are working. So not going to explain source code now, but yeah, maybe next time. Yeah, it's just good learning. Yeah. So okay, so that's enough for today. I'm gonna go disconnect this, close it down.